Hello guys, let's start revision of physical chemistry formula and short formula we are revising in this class. So first chapter is atomic structure. According to atomic structure there is a theory that is called Planck quantum theory, and energy of one photon is equal to h nu. Here is h is the Planck constant and nu is the frequency. Nu you can write like c by lambda. C is the velocity of light and lambda is the wavelength. Photoelectric effect, h nu is equal to h nu naught plus half mv square. This formula we can use for photoelectric effect. Here h nu naught is actually threshold. Nu naught is the threshold frequency and h nu naught is the work function. H nu is the energy of incident light and half mv square is the kinetic energy of electron. Ejected electron means photoelectron. Now some formulas which are used for Bohr model. MVR means angular momentum is equal to nh upon 2 pi, and energy of electron is equal to E1 upon n square into z square. So that will be equal to 2.178 into 10 raised to power minus 18 minus 2.178 into 10 raised to power minus 18 z square upon n square joule per atom. If we convert it into electron volt, then it will become minus 13.6 z square upon n square electron volt. So we can say actually energy of electron is directly proportional to minus z square upon n square. Z square upon n square. What is z? Z is the atomic number. Atomic number. And n is the shell number. Next one is r. R means radius. That is equal to n square upon z. And it is equal to 0.529 n square upon z. So we can say r is directly proportional to n square upon z. Velocity of electron. Now what is r? R actually it is the distance of electron. R is the distance of electron from nucleus, or we can say radius of a shell. V, velocity of electron, is equal to 2.18 into 10 raised to power 6 z by n meter per second. So we can say V is directly proportional to z by n. De Broglie wavelength. De Broglie wavelength we can calculate by the formula lambda is equal to h by mc, or lambda is equal to h by mv. V we can take for any microscopic particle like electron, neutron, proton, and C we can use only for photons, and it is applied for microscopic particles. So h lambda is equal to h upon p. M is equal to mass, lambda is equal to wavelength, v is the velocity, c is the velocity of light. So value of c we can use, that is 3 into 10 raised to power 8 meter per second. And velocity of light we can use when there is a movement of photons. Wavelength of emitted electron means that is called Rydberg formula, in especially in hydrogen spectrum. So nu bar, that is a wave number, that is equal to 1 by lambda, and it's equal to r z square upon into 1 by n1 square minus 1 by n2 square. When electron jump from n2 to n1 shell in hydrogen spectrum, r is equal to Rydberg constant, that is 1.01 into 10 raised to power minus 10 raised to power 5. Value of Rydberg constant. Number of photons emitted by a sample of hydrogen, that is equal to delta n into delta n plus 1 by 2. Heisenberg uncertainty principle. Uncertainty in position and uncertainty in momentum. Multiplication of that will be greater than or equal to h by 4 pi. So delta p, that is the uncertainty in momentum. Quantum number are of four type: principal quantum number, that is denoted by n; orbital angular quantum number, that is denoted by orbital angular momentum of electron is equal to nh upon 2 pi; azimuthal quantum number, that is L, it tells us about shell number of orbital in a subshell, can be calculated like as 2l plus 1. For S subshell, L is equal to 0. For P subshell, L will be 1. For D subshell, L will be 2. And for F subshell, L will be 3. Maximum number of electron in a particular subshell is equal to 2 into 2L plus 1. And orbital angular momentum is equal to L is equal to h by 2 pi root L into L plus 1. L is the azimuthal quantum number or subsidiary quantum number.